Section 10.2 is on products and quotients of functions. So in the last section we just looked at what functions were and addition and subtraction of functions. Now we're going to do product and quotients of functions. So from your textbook on page 48, it says, 488, sorry, it says consider the graphs of the functions fx and g of x. Copy the table and use a graph of each function and complete the columns for fx and gx. And in the last column, we're going to enter the product of the values of fx and gx. So, fx is the blue. At -4, fx is -6. At -2, it's -4. 0 is -2. 2 is 0. 4 is 2, and 6 is 4. Gx is the red graph. So if we do the same thing at those x values, or input values, what is the output, or the y values? So at -4 we have -3, -2 is -2, -1, 0, 1, and 2. So when x was 6, my gx value was right there at 2. So and then it says in the last column we're going to enter the product of the values of fx and gx. So that's all we're going to do. It's just that we're going to multiply and write what those values are. So -6 times -3 is 18. -4 times -2 gives us 8. -2 times -1 is 2, 0, 2, 8. So if we look here, we're going 18, 8, 2, 0, 2, 8. So we have a repeat in values happening there. Now our y values can repeat, but if our x values repeat, we don't have a function. So it says predict the shape of the graph of px, then copy the graphs of px and fx and gx and sketch the graph of px on the same axis. So I've pasted it on there so you don't need to do the fx and the gx. But based on those values, what does it look like we're going to have? What shape will this graph be? Well, if you remember from our graphing in the other units, when the y values start to repeat themselves, that means that we have a quadratic function. So that means we're going to have a parabola. So if we plot these to see, at -4 we were way up here at 18. -2 was at 8, so again up there. 0 we were at -2. 2 we were at 0. Sorry, at 0 we were at 2. Read that the wrong way. So 0 we were at 2. Did I put that in the wrong spot? -2 and 8. Oh no, that was supposed to be right there. That's the one I put in the wrong spot. Sorry. 0 was 2. So right here. At 2 we were at 0. 0, 2, 2, 0. At 4 we were back at 2. And then at 6, we were up at 8. So back there at 8 again. And over here it was up at 8. So our graph would look like this. Oops, pretend that. Well, that's a bad curve. I better redo that one. So it would look like that. So it says, how are the x-intercepts of the graph of px related to those of the graphs of fx and gx? Well, the intercept are all the same. The x-intercepts are all the same. Determine the equation of the functions of fx and gx. So fx and gx are both linear functions, so it's easy enough to get an equation from there. So if I look at my x-intercept, or sorry, my y-intercept for my fx graph, this is for 2a, fx, my y-intercept, is equal to -2. And my slope then, I go up 1, 2 over 1, 2. So it's a 2 to 2, or 1, if I reduce that, it's just a 1 to 1. I didn't have to go quite so high. So my equation of f of x would be 1x, or just x minus 2. For the g of x, suppose I had not a lot of room. Okay. My g of x graph, that's the red graph. My y-intercept is at -1. And if I do my slope, I go up 1 over 1, 2. So m is equal to 1/2. So the equation for g of x is going to be 1/2 x, or x over 2 minus 1. So 2b says, how can you use the equations of fx and gx to write the equation of the function px? Well, the way we got our points for our function of px was to multiply them. So that's what we would do. So we're going to see if that'll work. So if I multiply the function of x times the function of g, I should get p of x. I'm just going to pause for a second. Okay, so fx was x minus 2. Gx was 1/2 x minus 2, or x minus 2. So if I multiply these out, 1/2 x times x is 1/2 x squared. -2 times 1/2 x is just negative x. -2 times x. Oh, sorry, is one. Where am I here? Lost my spot. -2 times 1/2 x for my insides. It's going to be negative x. And then, I better write that down. X times -2 is -2. And then -2 times -2 is a positive 4. That should be a -2x. Did I write that down wrong? Yes, I did. I wonder why it's not equaling. It should have been x minus 2 and 1/2 x minus 1. Okay, so let's do that again. So x times 1/2 x is -1/2, or is 1/2 x squared. -2 times 1/2 x is negative x, and then negative times x is negative x, so there's a -2x. -2 times -1 is positive 1. So then it says verify to see if this works. So we could change this into our vertex graphing form, but that would take a little bit more work than we need to. So what you could do to check this is to just actually pick some points. So if I pick the value of -4, when I'm done, I should end up with 18. So if I do 1/2 times -4 squared minus 2 times -4 plus 1. So -4 squared is 16, times 1/2 is 8, right? 4 squared, 16, 8. -2 times -4 is a positive 8, plus 1. Why didn't that work? Plus 2, that's why. 8 plus 8 is 16, plus 2 is 18. So it worked for that one, so it's going to work for the rest. Number 3. A, what are the domain and range of the functions of fx, gx, and px? So my domain for f of x I could have used any possible real number that I wanted to, right? It can be all negative. If I do my number line, I could use anything in either direction. I'd end up with some fractions, but that's okay. Oops, for g of x, my domain is the same thing. It's going to be all real numbers, because I could go all positive and all negative numbers. And for p of x, my domain is again all real numbers. I could go left or right in either direction and still find an answer for it. So it says, is the relation between the domain and range of fx, gx, and px the same as it was for addition and subtraction? And explain. Well, it is. Whatever you graph in your fx and g of x, when you multiply them together, it's going to affect your product. So in this case, they ended up, your domain was all exactly the same. In our addition ones, they weren't always the same. It depended on what values you had in there. So our rules then, or guidelines for combining functions through multiplication and division, similar to the addition and subtraction ones. If you're finding a new function hx, you can find it by multiplying two functions together. So fx times gx. Another way to write that is to write f times g of x. Means the same thing. If you're doing quotients, then it means you're dividing two functions, so fx divided by g of x. You can rewrite that as f divided by g of x. And the only thing to remember with quotients, because you have that denominator, x cannot be 0. Or actually, more specifically, g of x cannot be equal to 0. Now you can't have a 0 in your denominator. The x could be a 0 value. That's why I had to change that. But when you find the function of g of x, or the function of x, if it equals 0, then can't use it. Okay, example 1. Given fx is equal to x squared and gx is equal to square root of 4x minus 5, determine the product, state the domain and range. So, my product then is just x squared times square root of 4x minus 5. So that just equals x squared times square root 4x minus 5. Because I'm working with a radical here, I can't do anything, I can't pull anything out, and I can't multiply if I don't have the same terms in there. So my domain and range. So I have to look at each one of them to see what I've got. So my domain for f of x, no matter what I put, if this is my 0, if I put a negative value in, I'm going to have a positive result. If I put a positive value in, I'm going to have a positive result. There's no value that I can't put in there. So in this case, x is just an element of real numbers. For the g of x, I have that square root of 4x minus 5. So that means I have 4x minus 5 cannot equal 0. Okay, it has to be greater than 1. If it gets smaller than that, I guess I shouldn't put a not equal to. It should be greater than equal to 0. It can equal 0, but if it equals a negative 1 or a negative 0.11111, whatever it is, then it won't work because I can't have a negative value. So that means 4x has to be greater than 5. I divide by 4. X has to be greater than or equal to 5 over 4. So if here is 0, here is 5 over 4, which is the same as 1 1/4. So anything to the right of 1 1/4 is going to be positive, but anything to the left will give me a negative value. So my domain for the g of x function is x is an element of real numbers, but x has to be greater than or equal to 5/4. So for hx then, I do a comparison. This time it's easy because I couldn't multiply anything together in here that was going to give me any new values, just because of the laws of radicals. So what I do then is I look where on my two graphs, or on my two number lines, and they call it a sign analysis. This, the way I've set this up here, it's called sign analysis. So I look for where are my sign analysis for each function positive. So in this case, it's positive from here on. So then that means my domain for my hx values is from 1 1/4, that 5/4, it's positive. Everything else is going to be not 0, it's going to be negative. So my domain for the product of fx and gx is going to be x is greater than or equal to 5/4. And x, of course, is an element of real numbers. Okay, example 2. Let fx is equal to x plus 2 and g of x equal x squared plus 9x plus 14. It says determine the equation of the function hx is equal to f divided by g of x. So to determine that equation, we actually have to then substitute and do some solving. So hx is equal to, and remember f divided by g of x is just the same as saying f of x over g of x. So in this case, that's x plus 2 divided by x squared plus 9x plus 14. So in order to solve this, I need to factor my denominator and see if I can reduce it at all. So using product and sum, my product is 14, my sum is 9, so that's going to be x plus 7 and x plus 2. So I can cancel my x plus 2 and my x plus 2, so that means that my new equation of the quotient of fx divided by g of x is 1 over x plus 7. Now from the last unit, we know that when we have a factor that cancels, then we have a point of discontinuity. So we have a point of discontinuity. So this is to help me kind of find b. Point of discontinuity at x is equal to -2, or x plus 2 equals 0, and you pull it over so it's an x is equal to -2. The factor that I'm left with gives me the asymptote. So my asymptote is at x is equal to -7. And I can't remember what I did in the last unit, if I put this as a not equal to or not equal to. Either way, it's okay. That just means that at x is equal to -7, or at -7 there, you're going to have that dotted line. And at the -2, you're going to have a open circle. Okay, so now they want us to sketch this on the same coordinate axis. So you have a couple of different ways of graphing this. I'm just going to use a table of values so you can see it that way. You could just graph, I mean, x plus 2 is easy enough to graph because that's just going to be a straight line. G of x, you would have to change it into vertex graphing form or use the table of values. And then to do the hx function where you've found the quotient, you could just do the table of values for that. So my input values, I'm just going to do a little chart here. F of x, g of x, and h of x. So I know that I have to go at least to -7 in my negative values because I have that asymptote there. And I want to go as far down at least as -2 and probably a few positives after that. So I'm just going to pick a few negative values in here. I am going to do -8. When I put a -8 into x plus 2, that gives me a -6. If I do a -7, that gives me -5. Let me try. I'll do -5. That gives me a -3. -4 gives me -2. Actually, I'm going to do all these. -3 is equal to -1. -2 is 0. -1 is 1. 0 is 2. And then 1 leaves me with 3. So I'm not going to plot every single one of these values. I just want it for you to so that you have a clearer picture. And I mean, the fx function, because it's just a linear function, is a nice straight line. So it would be easy to draw without a table of values. So let's try it with gx. If I substitute a -8 in there, I'm going to have 8 squared is 64 plus or minus 72 plus 14. So that's going to be 64 and 14 is 78 minus 72. So that gives me a value of 6 if I did that right. Correct? 64, 48, or 64, 78. It's a negative. Yep. And then minus 72, 78 minus 72 is 6. Okay. So I use -7. 49 minus 56. So, not 56. Minus 63 plus 14 gives me 0. Okay, and the rest of these I'm just going to plug the values in because I've already calculated them. So -5 is a -4. Sorry, I missed -6. -5 is -6. Did I goof that up here then? No, I skipped over that one completely. Okay, so -5 is a -6. -4 is -6. -3 is -4. -6 would have been -4 as well. -2 is 0. -1 is 6. 0 is 14. And 1 is 24. So if I do my divides here, fx divided by g of x would be -6 divided by 6, or I can just put it right in here. So what happens when I go 1 divided by -8 plus 7? Well, that gives me a 1 over -1, which is just -1. So if I look on my chart here, -6 divided by 6 gives me a -1. So I don't even have to plug in there. I can just do my division based on here. -5 divided by 0, can't do that. -3 divided by -6 is a positive 1/2. -2 divided by -6 is a positive 1/3. -1 divided by -4 is a 1/4. 0, 1/6, 1/7, and 1/8. Okay, so now I can start to plot these. Okay. So, on my graph here, my x's, I need to go all the way over to -8. I know if I call this point here -7, at -7 I know I'm going to have an asymptote, so I'm going to make this spot here -7. For my fx is equal to x plus 2, so if this is, I call that 2, and then I'm going up 1 over 1. So my graph is going somewhere like this. So that's my fx graph. Gx graph, I'll do that one in, I'll do that one in red. So the gx graph is that parabola. So if I take a look at the parabola, where do my points start to repeat? Well, I have an x-intercept at -2 and 0. Which is approximately right there. So I know I have that point there. I have another x-intercept at -7 and 0. So I know my graph is going to go like that. And then the points in between, where's my repeat? Are in between -5 and -4. So somewhere in here, down about here, is where my values are going to start to repeat themselves. Okay, so now for the hx graph. So hx is going to be in purple. So at -8, I had a value of -1. So if this is -8, -1 we'll say is about right there. At -7 and 0, I had a asymptote. So right here is an asymptote. So then that means that my other points here, as I got close to -7, would get close to that value and would curve this way over there. If I do my other values on the other side of -7, at -5, it was at 1/2. So this is -5. 1/2 is about right there. -4, it was at 1/3. So getting even closer. And then 1/4. And then at -2, it was 0. But remember, at -2, I have a point of discontinuity. So I'm actually going to have an open dot right there. And then my graph would continue through. -1, it was at 1/6, so it's getting closer. And then at 0 is 1/7. And at 1, it's over here. So my graph is going like this. It's going down. It hits that point of discontinuity. It stops, and then it starts up again. So C part says state the domain and range of just hx. Okay, so if I look at hx, I can do the domain and range of the first two. So for x is an element of, or for f of x, when I had, if I put in a -2, I have 0. -3 is going to be a -1. So at -3, I have negative values. And everything to the other side of, or at 2, or here, -2, then they go positive. So it's negative up until that -2, and then positive on the other side. And x is an element of real numbers. I can use every single one for my domain. For the g of x function, I can use every single positive, or every single element in there. Because no matter what I put in there, I'm going to end up with a positive value. Or sorry, not with a positive value. I'm going to end up with a value. It's going to be positive and it's going to be negative. So in between -3 and -2 here, I went from a negative value to a positive value. So same thing here, after -2, it went positive, but on the other side of -3, oops, that should be negative. So it was negative here until we got to, where are we? At -7, it turned to 0, and then it was positive again. So up until -7, then it was 0, and then it was positive values. And then on that side, anything above -2 gave us positives. So for my h of x, so I could put any value in there. It's going to be giving me positives and negatives. But now if I take a look at this graph, anything, I can use any value in there but -7 and -2. At -7, it gave me negatives, so I can't use that. And then at -2, I had that point of discontinuity. So for my domain for that, I can use real numbers, except x cannot be -7 and x cannot equal -2. My range then, so for my range, I'm never going to get that to equal 0, because this point here, remember, it was a point of discontinuity, so you have to watch that. So, but my y value will never be 0 because of that point of discontinuity. So my range, y cannot equal 0, and if I continued in between there, if I go look at here between 1/4 and 1/6, what I'm missing in between there is that 1/5. So y cannot also equal 1/5. Well, I missed inserting a page here. I'm just going to pause so I can insert the other page. Okay, sorry about that. I missed that one page. So, students at the school decide they're going to sell t-shirts as a fundraising activity. If the fixed costs are $250, the cost per t-shirt is $4, and they intend to sell shirts for $10 per shirt. Then write in the equation for cost, revenue, and profit. So my cost. So cost is based on the number of shirts, and we're going to say that X is the number of shirts. Your cost of your shirt is $4 per shirt. Your revenue for your shirt is $10 times the number of shirts you sell, and then your profit then is going to be your revenue minus your costs. So another way to look at this is you could, because the cost per shirt is $4, but you've also got that fixed cost of $250. So you could write your CX as 4X plus $250. So if I did my revenue minus my cost, my revenue is 10X, and then that's going to be minus 4X minus that 250, because it would be like negative 4X plus 250. So that's going to be 6X minus 250 is how you would calculate your profit. So for purposes of finding your profit, you need to also include that fixed cost in there. So it says how many t-shirts do they need to sell to find their profit. So what you need to do then is you need to go onto your calculators and you would enter, that's the easiest way to do it. You could graph this if you wanted to. So graph 4x plus 250 and 10x plus 250. So if you put this in your calculator, y1 is equal to 6x minus 250. And then you adjust your windows. So in your window, then well, let's adjust your window first. You need to adjust your window because you want to see, at the very least, if they sell nothing, they're going to have a $250 loss. So you want to adjust it so that your Y is going from negative 250, and then just a good educated guess is going to be, you know, if you sell 50 shirts, that you're going to make $500, and that's going to at least cover the cost of that. So 50 is a big number, but you could do it in between there. So when you put that into your calculators, what you're going to do is look at so you're going to look at, and maybe I'm going to pause here and put it up because that might be better to see. Okay, well, my calculator that comes up on the smartboard isn't cooperating right now. But basically, then what you can do on your calculators, enter in y1 is equal to 6x minus 250. You adjust your y value so that it's in between negative 250, because that's the point where if you sold no shirts, and 50. Your x values then, again, you could go, I think I set mine when I did it on the graphing calculator between 0 and 50, and I went up by 5. Excuse me. On the x scale, and this one I went up by 10s on the x scale. So when you put this in your calculator, your graph is going to look like this. This will be your coordinates, and then your graph itself is doing this. Okay? So this is when you have 0 shirts here. That means you have a negative 250. This point here where it crosses the x-axis is the point where you are going to start making a profit. So if you go on your calculators and do the second, excuse me, calculate, and do either the 0 or the intercept will work, but let's do the 0 because that's what we're calculating. It'll ask you for your left bound, so move it close to that line. Hit enter. Right bound. Move it above the line. Hit enter. Guess. So it says 41.67. So basically at 41.67, that's this point right here. That's when you're going to make a profit. So basically, that's when you're going to break even. So to make a profit, you're going to need to sell 42 shirts. Will make you a profit. It says, what is the domain and range of this function in this problem? So your domain, x has got to be everything greater than equal to 0, and your range, you can't go less than negative 250 because it's not going to cost you more than that for your shirt setup. So it's going to be everything greater than equal to negative 250. Okay, f of g of x. So we're going to find f of g of x and state the domain and range if f of x is equal to square root x and g of x is equal to square root of x minus 3. So this then is the same as saying fx times gx. So that's equal to square root x plus 3 times square root of x minus 3. So when I multiply those together, That's equal to the square root of x plus 3 times x minus 3. It doesn't cancel my square root because I wasn't multiplying the exact same thing together. I would have had to multiply square root of x plus 3 times square root of x plus 3 in order to get rid of that square root sign. So this is the same as square root of x squared minus 9. So that is my new function. To find your domain, we need to go to that first step. So my domain of x plus 3 and x minus 3. So for right now I skip my little brackets there. So I have x plus 3, that was my first one, my fx. If I do my sign analysis, at negative 3, I would have, and anything above, I'm going to have negative values. Anything at negative 2, let's say negative 2 or anything above that negative 3, I'm going to have positive values, and I would continue to have positive values. For x minus 3, at 3, I would have 0, and everything above 3 would be positive. Anything going to the left of this, so let's say at negative 3, so at 3 I wouldn't have, oh, I keep looking at the wrong equation. X minus 3 I would have positive, but if I went less than that, I'm going to start to have negative values. So then when I look at my hx1, so that's x squared minus 9, which is a combination of these two, where do I have positives? Because I'm dividing, right? So I'm dividing this function by this function. A negative divided by negative means that after that negative 3, I will have positives. Positive divided by negative means that these are going to be negative. Positive divided by positive means that these are going to be positive. So to see for hx, x is going to be less than negative 3, or x is going to be greater than 3. That's where I'm going to have positive values. So if I look at what's in common, so just for hx, but what's in common between all of these, they are positive when x is greater than 3. So for hx, my domain is going to be x is everything greater than or equal to 3. I should put equal to's in there. And my range, well, y is always going to be greater than or equal to 0. Okay. F divided by g of x, and find f divided by g and state the domain and range if fx is x plus 2 and gx is equal to x squared plus 9x plus 14. Isn't that the one I just did? Did I do these twice? No, but I did do that one. Okay, I put that on there twice, sorry. So that's where I'm going to stop. I'm not going to bother doing a problem-solving one. There's really good examples in the textbook, so you can have a look at those if you need any help.